If you're not speaking, good morning, good afternoon. I am aware of people all over the world, depending on which time zone you're in. My name is Beatrice Spadaccini, and I have the pleasure to welcome you to the very first roundtable discussion organized by MARM, which stands for Mentoring African Research in Mathematics. This event is specifically focused on how mathematics as a discipline can help solve or better address the world's most pressing problems, including infectious diseases, the climate crisis, economic inequality, etc. A few words about me. I'm a print and audio journalist. I'm originally from Italy, and I work for Internews. It's a media development organization that works all over the world and supports the capacity building of journalists. At Internews, I'm responsible for building out the health journalism network and creating a community of media practitioners who are passionate about covering global health and have access to the tools and resources they need to do their jobs well. Let me start today's event with some basic logistics. We will have this space for a total of 90 minutes. We have 9 distinguished panelists from various parts of the world, including Kenya, Namibia, Brazil, UK, and Italy, plus many more guests that I don't know where you're from, but I assume that there's a lot of people from different parts of sub-Saharan Africa and other parts of the world. For your information, yes, this event is being recorded, and it will be made available on the MARM website in the next few days, so you can always share it with colleagues who are not present at the moment. Let me start with a brief introduction of the panelists, and once I say your name, if you could just introduce yourself and say hello by unmuting yourself so that the participants can put a name to a face. That would really help in this Zoom world where we see each other in little boxes, but at least we'll hear each other. And then I'll ask 2 of the panelists, specifically Professor Martin Mugocci and Professor Frank Newman, to say a few words about the event itself and the meaning of this event, the objective of this event, and about MARM as an organization, so we can hear a little bit more about MARM. Okay? And then we'll begin the roundtable. So let me introduce the 9 distinguished guests that we have here today to everyone else on this call. we have Professor Josephine Kagunda, who is with the University of Nairobi. She has a PhD in applied mathematics and has studied in Lorraine, France as well, and did a thesis on mathematical analysis and dynamical system modeling. She is an expert, and she's part of the Commission for Women in Mathematics, representing Africa and Kenya in the regional workshop for Africa. She has also done quite a bit of work on gender gap in mathematical and natural sciences, so we're going to ask her a few questions about gender. Then we have Professor Giovanni Marelli. He's based at the University of Namibia, and he's an Italian citizen and studied at the University of Trieste. His interests range from mathematical physics to algebraic geometry. I apologize. Let me say, Professor Josephine Kagunda, could you say hello so everybody sees you? You have to unmute yourself.
Hello everyone, I'm Josephine. I'm in Nairobi. It's around 5 p.m. People are going home, but I'm glad to be part of this discussion. Thank you.
Thank you so much. And Giovanni Marelli, maybe you can say hi.
Yes. Hello, good afternoon or good morning.
Thank you. We also have Professor Martin Mugocci, who's the main ideator and creator of this event. He'll tell you a bit more about it. Actually, perhaps Martin, he's also the chairman of the Department of Mathematics at the University of Nairobi. And he has a PhD from the University of South Africa. And his specialty is the theory of point-free topology, a discipline that goes back to the times of the great pioneers in mathematics. He spent a period of study and research at the University of Buffalo in the United States, and he plays a very active role in the education of young people and in the study of mathematics. Perhaps I'll take this opportunity, Martin, for you to say a few words about this event and to say hello to all the guests that are here today.
Yeah, hello. I'm based in Windhoek, Namibia. I just migrated to Nairobi right now. But I'm in Windhoek together with Giovanni, who was, talked about just earlier on. And yes, I mean, this is an event which is, you would call, it's a non-technical event and also round table. We are not sitting around a round table, but this is, just to get acquainted with what mathematics, can do, in our day-to-day life. What is amazing is that, this has developed from our, our collaboration efforts that are going on. Sometime last year, we took an initiative to apply to the MARM grant, which is mentoring African research in mathematics. And, we were pleased to, to receive that, to get that grant approved and to start working with, Letterio Gatto, based in Torino, Polytechnico. And it's, so from that, now this idea of a round table started evolving, where we really just get to know each other in the various places that we are, and also just having a nice informal discussion and come up, with something that is really, exciting, where we can now, look at future engagements with one another in the various regions. So it's been a nice journey to, in the development and preparation of this particular discussion.
Thank you, Martin. Thank you so much for these words of introduction. I would like to also introduce Frank Newman, who is a professor at the University of, now you guys are going to Frank, you're going to have to help me because I'm going to butcher. Leicester in the UK. And perhaps you can say a few words about MARM and introduce MARM and maybe a few words also about your specialty.
Yeah, hi. Thanks very much. I'm very thrilled to be part of this roundtable discussion, and I'm very happy to see that the MARM project for the 6th round is going ahead, and Letirio has already started doing something with the people in Martin and Letirio in Nairobi. In Namibia. I know he's now in Nairobi, but so I am actually the chair of the London Mathematics Society's MARM board. So MARM stands for Mentoring African Research in Mathematics, and it is basically administered in the UK and Europe, if you want, by the London Mathematics Society, but there's a partner organization involved, namely who's taking care of the choice of African institution involved. This is the African Mathematical Millennium Science Initiative, and both together also have support from the International Mathematical Union. And I can say a little bit about that, so maybe I can share my screen for a moment. Let me see if I can.
So while you share your screen, I'm going to remind participants, I hear someone typing, so please remember to mute yourself if you're not speaking. Back to you.
Yeah, I just put up a little map. I hope you can see that. Does it work?
Yes, we can see it.
Yeah, so you see here a map for the first 6th round. We have not updated yet, so I should say that the current rounds actually, besides Letirio's involvement with the University of Namibia, we also have Professor Giorgioli in the University of Felix Houphouët-Boigny in Ivory Coast, the Adama Science and Technology University in Ethiopia with Professor Mikhailov in Bristol, Université Gaston Berger in Senegal with Professor Donarski in Cambridge. And I just like to say a little bit, so they just started, and of course the situation at the moment is complicated. We try to do as many possibilities as it works in the moment because travel is not possible and restricted, so we have to do some other things. But I'm really happy to see that all 4 partners, mentorship are going out for a good start. And so let me just mention the Mentoring African Research in Mathematics, MARM, basically pairs African institutions which were chosen by African Mathematical Science Initiative, Millennium Science Initiative, through an open call, and then will be paired with institutions mostly in the UK, but not only, as you can see from the map. And as you know, Letirio is in Torino. We had also before people in Spain and France, Germany, and other places, as you can see from the map, including Australia. So the idea is really to have a small group of scientists and also postgraduate students and postdoctoral researchers who team up with some mentors in the UK or Europe in order to do some scientific research and projects. And this can have many ways. It can be research collaboration, as is classically. It can be some mentoring of PhD students, master students, and things like this. So there's a lot of openness here. And I think it went very well. You can see here all the partnerships we had since about 2007. At the beginning, it was also financed by the Wellcome Trust and the Leverhulme Trust in the UK. And the moment it is mainly financed by the LMS and the IMU through MSci. And yeah, I don't want to say too much more. You can see this map. If you have want to have more information about MARM, just go to the London Mathematics Society's webpage, and you will find it there. If you just Google MARM LMS, you will find more information. And if you are happy to ask more questions, I'm happy to answer them later as well.
Perhaps, Frank, perhaps you can put in the chat the link to the MARM website. That would be really helpful for everybody to have.
I will do that. Let me just stop sharing my
screen. And I'm going to just have another gentle reminder to everybody to make sure if you're typing, we don't hear you type. So, because it can be distracting. Let me continue with the introduction. We have Professor Philippe Ngare as well. He has obtained his PhD at the University of Linz and is a professor at the University of Nairobi. His expertise is in finance, financial risk management, financial engineering, and many other related topics. and he has recently co-authored a paper with another distinguished guest here, Patrick Weke, on credit quality evaluation with social network data. Maybe Professor Ngare, could you say hello so everybody sees you and puts a name to a face? Professor Ngare online? I'm hoping so because I'm planning to call on you. If you are, perhaps you have to unmute yourself. So maybe he's not yet online. So let me go on to, perhaps Leterio, you could text him, making sure he's on.
Yes.
Let me go on to the next guest, and not guest, but panelist. We have Professor Winifred Mutuku. She's a professor at Kenyatta University, and her research interests are in mathematical physics. And Professor Mutuku, could you say hello to everybody so we can see you?
Hi, everyone.
How are you doing today?
I'm fine, thank you, and I'm glad to be part of this discussion. And I'm hoping that the deliberations will be impactful in the uptake of mathematics, as well as appreciating the application of mathematics in our day-to-day life. Thank you very much.
Excellent. Thank you so much. I would like to introduce next John Aguirre, who is more of a classical pure mathematician, and he is an expert of operator theory, a branch of the functional analysis. He's a local referent of the MARM program at Maseno University. Professor Aguirre, could you say hello to everybody?
Hello, good afternoon, good morning, everybody.
Professor Aguirre, where are you based?
I'm based at Maseno University in Kenya, western part of Kenya, right on Lake Victoria. Lake Victoria is the largest freshwater lake in Africa. So
Great.
I teach, sorry?
Go ahead.
Right now I'm in Kisumu. Kisumu is about 25 kilometers from Maseno, so I commute to work every day. And my area, as we have said, is on operator theory. So I teach operator theory, functional analysis, real analysis, and topology here at Maseno. Thank you very much.
Thank you very much. Let's go to Professor Paolo Piccione, who is an Italian mathematician, and he lives and works in Brazil. And he's a professor at the University of São Paulo in Brazil, one of the most important and international recognized research center. Paolo, could you say a few words about where you're in Brazil, but just say hello to everybody so we can see you.
Hello, I hope you can see me and hear me. My name is Paolo Piccione. Thanks for the introduction. I'm very grateful to the organizers for inviting me to this roundtable. I am here in my workspace at home because, as you know, we're in almost total lockdown due to the sanitary emergency in Brazil. So, but despite this situation, I'm very happy to be here, and thanks for having me.
Thank you so much. Let's go next to another distinguished panelist, Patrick Weke, and he's a professor of actuarial science at the School of Mathematics at Nairobi University, and he's an expert of mathematical models for finance predicting and management. Professor Weke, could you say hello to everybody?
Hello, everyone. Let me, at the onset, thank MARM, not just for organizing this, but for the scholarships and assistance that they have given to the School of Mathematics, University of Nairobi, to LMS, and also to AMSI. I'm quite happy to be here. Thank you.
Thank you so much. So this is exciting. We are at almost 9:30 and we're going to start the discussion. How this is going to work is that we have identified 5 questions, specific questions, centered around the role of mathematics in addressing the world's pressing problems, most pressing problems. We are in the middle of a pandemic, global pandemic, a global health crisis. It's been almost a year, and it's still we're still in an emergency to some extent. We've adapted, but vaccines are on the horizon, and hopefully by this time next year we'll be through it. But many people have lost their lives, and I really want to really think about how mathematics, I'm not a mathematician, obviously, I'm a journalist, and I was not very good in math at all. So, but I can see the value of mathematics, and I would like to explore this question with a first question is really, does mathematics, for instance, have a role in managing or preventing pandemics? So I'd like to start with this question, which is extremely relevant in the experience that we're having globally now, because we are in the middle of a pandemic, and there may be future pandemics because infectious diseases will not finish with the COVID-19. So I would like to pose this first question to Professor Josephine Kagunda from the University of Nairobi to really help us reflect how does mathematics can help us manage and prevent pandemics now and in the future. Over to you.
Thank you, Be. I am grateful for this meeting and also the kind of discussion that we are having about the role that mathematics play, especially in fighting infectious diseases.
Josephine, sorry to interrupt you. Josephine, sorry to interrupt you. Are you intentionally not putting the video on? Just want to make sure, because we don't see you.
Okay, I'm just fearing for my network. Let me just put it on so that you can communicate.
Thank you.
Okay, welcome. So I was just talking about the position, and we have found ourselves in since December of 2019, when we got the first case of COVID-19. And life is not going to be the same for us for a very long time, because even if we have the vaccine, we still have very many questions that are unanswered about the virus, the transmission, the symptoms, etc. So mathematics comes in because the models that we develop, they help us to predict what is going to happen next, how different interventions might change that, and how the pandemic is going to evolve, what effect the social interventions are going to have, and also the contribution of the society, because the measures may be there, but people have to obey. So you may have noticed that people are very keen about the numbers, especially in the first few days when the numbers were 2, and then we got 10, and then we got 30. And the more the numbers came, the more people became aware of the disease, and they took measures more seriously. That is a kind of a mathematical model where you see if today we had 1 person, a lay person is able to tell by next week it may be having 100 people, and I don't want to be among that number. So we use the mathematical model to characterize the transmission of the disease so that we may be able to draw a map of how the disease is in the short term, so that we can be able to make a prediction in the long term, and maybe help those who are making decisions, and those who are giving direction, and those who are putting in place policies and control measures. So, and we do that by looking at the history that we have. Our COVID-19 history has been very, very short, because it is a very new disease. There is nobody who has immunity. and the biological classification of the disease, although it is similar to other coronaviruses, classes and groups. This one is very unique because none of it has been introduced in the world ever. So nobody has the immunity. So the general idea behind mathematical modeling is to have a map of the population that we have. Then we cluster them into groups so that we can be able to read the characteristics, the transmission mode from one point to the other inside those groups. Then we can capture the rate and be able to discover some dynamics using mathematical models. And the best thing with mathematical models is that I don't have to use human beings. I represent human beings with the parameters. So I'm able to change the parameters at will. So the kind of dynamics that we are having right now for COVID-19, we have discovered that this disease is actually being driven by contact. So it is very important to characterize the kind of contacts that are making the disease highly contagious. That is why we are talking about wearing masks and putting in place social distancing facilities in the meeting points, in churches, in the public transport, and those kind of things. So mathematical models are able to predict this kind of a measure, what kind of an effect it is going to give us, so that we are able to track and be able to see how much of what gives us how much results. Then we usually ask ourselves sometimes, are these models right? Because, like, for example, the models that were developed for Nairobi and Kenya in the early March, they had predicted that the curve is going to peak up around November. But we found around August, the curve went up and down and people thought, yeah, okay. And so the containment measures, they were relaxed a bit. Now the disease has picked up again. So because of the many unknown factors that are surrounding this virus, sometimes the models may be not really wrong, but the representation is limited. And the problem that we have had right now in Kenya is the role of the people without the symptoms. So when we are doing the modeling, we have to take care of that. It is very critical to know that 90 or 85% of the people in Kenya, they have no symptoms at all about the disease. So mathematical model comes in right there to be able to backtrack and see what is the role of this asymptomatic person who is transmitting the disease. Then we have a lot of things that we do not know about the disease. So the mathematical model comes in to help us to infer from that imperfect data so that we may be able to tell where do we want to be in the future. So since the information is not enough, we need many mathematical models so that this one can discover this and this one can discover this. When we put that together, then we are able to make a proper statement backed by scientific evidence.
Professor,
yes.
Sorry to interrupt you. I wanted to ask you something. Do you work regularly with the Ministry of Health, for example, in this time, given that the models are so important, and you mentioned contact tracing, people who are asymptomatic? Do you work with experts in the Ministry of Health to help them?
Yes, we are working. We have 2 projects that we are working, and the members are drawn from the doctors who are dealing with the patients in the hospitals. We have the grantors, that is the donors who are giving us the money. And then there are us, the mathematicians. We have data scientists who are helping us to mine that data and make sense out of it. When we combine all that, then we form a multidisciplinary team that is able to kind of direct the kind of idea that the government is looking for. So yes, we are working together with the Ministry of Health.
Thank you so much for that. And Professor Kagunda, I would like to ask also Professor Patrick Kugeweke at the University of Nairobi, who has applied mathematical models to predicting and managing natural disaster, to weigh in on this question from his perspective. Again, like, how does mathematics can help us manage this pandemic and prevent future pandemics? Maybe based on what Professor Kagunda said,
laymen in the room.
There are. I promise you there are,
Okay.
including some journalists.
I will be quite simple. When you talk about natural disasters, or when you talk about pandemics, take a case where you have a patient 0. And it starts from there and moves to the next and the next. When you look at the progression of the process, it is definitely a graph. And therefore, we must look at ways of studying this graph in a mathematical way. The layman would say, leave this graph to mathematicians. Hence, the need for mathematicians to come up with accurate models that we cannot describe here. To manage the graph, one, look at the speed of movement. Look at the speed of the spread. Look at how the disaster is causing this havoc. And then ask yourself, what model can I use to study what I would call convergence? When is it likely to end? When is it likely to peak? And that is important for national development. So that even for COVID-19, a country would want to know how long are we going to be in this situation. And therefore, well, there's a Russian mathematician a long time ago called Markov, who applied what we call the Markov chain, how this builds up from one to another. And these are some of the things that we do in order to look at the speed of the spread, but also to be able to judge how long it's going to take and the magnitude of the havoc for us to make a good decision to advise our various governments. So in a nutshell, that is what I would say the mathematicians would do in terms of modeling of disasters, modeling of the pandemics, and the like. Thank you.
Thank you so much for this. I'd like to actually move to the next question, but I did have a thought about what you were saying. With all these modelings, I would assume there's also technology that plays a role in helping mathematicians kind of make sense of all of the data. Is that the case? Either one of you might want to weigh in on that.
Maybe I can go fast. The technology comes in when you want to decide on the accuracy. Long time ago, I think people were using what I would call pen and paper or pencil. And the calculations were done mentally. Then we moved to calculators. We moved to computers. Now, when you talk about data collection, do you do it with a modern way with a phone? How is the analysis of the data collected done? How do you then feed this into this powerful computer? And this is where, as my colleague Josephine said, you need also data scientists, people who would then use artificial intelligence to get things accurately done. They would then use things like machine learning to get accurate information and accurate output of the model. So that is where the technology comes in.
Thank you so much. This is really helpful to understand all this data and all this amount of the modeling and how the machines can help and the technology can help. Let's move on to the segue to this question, which is, beyond pandemics, what is the role of mathematics in everyday life? This is question number 2. And for this question, I would like to go directly to Professor Winifred Mutuku, and I would like to pose this question to you, and I'll give you the word, Professor Mutuku.
Thank you very much for that opportunity. Many at times we assume the application of mathematics in our day-to-day life, and we fail to see actually naturally occurring applications of mathematics. And that is where we leave a gap between ourselves and maybe our learners, because they cannot see that connection between the mathematics we are teaching in class and the application of that mathematics, first in natural world, and again in solving our day-to-day problems. I'll take, for instance, in cases whereby we are teaching graphs and you want to look at quadratic equations. As a mathematician, you might not get the connection between that and a natural occurring event. And there are so many. I'll look at a banana. The shape of a banana can be represented by a mathematical equation. Anytime it's raining and we see a rainbow, that rainbow can be represented by a mathematical equations. There are very many examples of naturally occurring applications of mathematics. However, I will go back to the applications in solving our day-to-day problems. One of them has already been mentioned. We are using mathematics to address the problem of pandemics. We have mathematics being applied in many applications such as engineering, science, and technology. And when you look at anybody who is pursuing that field, you will find that one of the mandatory subjects is mathematics. And I will single out artificial intelligence, which Professor Weke has talked about. You might look at artificial intelligence as technology, but you look at the mathematics behind artificial intelligence. For example, artificial intelligence relies a lot on linear algebra. How does a computer recognize a flower? How does a computer recognize a face in a crowded mall? It is by storing that data in a matrix. Then you use that matrix to do analysis on it, then you are able to recognize a face. Artificial intelligence uses a lot of probability. That is mathematics. Artificial intelligence uses a lot of numerical calculation. That is on technology alone. We can look at another area, that of industrial cooling. Based on my area of research, I deal a lot with nanofluids. And we are looking at mathematics to address problems which are facing the world today. We are looking at a scenario, okay, for example, I would take a case scenario whereby we are looking at a perfect coolant, given the challenges which are brought by cooling using water. So I can ask
me, Professor, yes? Does cooling also apply, for example, to the vaccine and the keeping them cool and the chain for transporting vaccine? Because I don't know what that refers to.
Yes, cooling is any process which will removing heat where it is not required. Therefore, how do I apply mathematics? I can create a model to analyze the various fluids And at the end of it, using computer information, I can say this is the best coolant. On a very layman level, how can mathematics help somebody who is in the village, somebody with little education? Mathematics helps us manage our finances. For example, we are going towards the Christmas season. We have a father, a mother who wants to budget for their Christmas holiday. You will require mathematics to do a successful budget. Without mathematics, you'll not be able to see how much am I going to spend, how am I going to spend that money. Again, in the kitchen, how do I apply mathematics? If I have to be a good cook, then I have to understand the mathematics of ratios. Most recipes give us different ingredients in given ratios. It might give me a recipe for 3 people, but I am cooking for maybe 10 people. How do I apply my mathematics to change the recipe which has been given to cater for more people? Then lastly, when you are reading, we find that in every career, there is the application of mathematics. So my parting shot would be, there is no profession in the world that does not use mathematics. Thank you very much.
Thank you very much. Thank you. I will never look at a rainbow or a banana the same way again. Thank you for really kind of bringing us to a very concrete way of understanding mathematics in our everyday life. Professor Ogonjo-Aguirre, I would like for you to also weigh in into this question and give us some thoughts about how mathematics applies to everyday life. Thank you. Over to you.
Thank you very much. If I have to bring it closest, I can start with the graph. When always on our television screens, they talk of flattening the curve. Sometimes we have problems to explain what is this flattening of the curve, what is this curve all about. If you look at the curve which have been presenting on the TV, it is increasing, and it increases, and then it comes down. And sometimes in interpreting it to the non-mathematicians, I found it interesting because they were asking, what are these they are talking about all the time, flattening the curve? So this comes to pandemic. When it is increasing, the graph is increasing, with the time. And then it will come down, and then it will be parallel to the x-axis. But coming to your question, where is mathematics in everyday life? Everyday life there is mathematics. Beginning in your house in the morning when you wake up. You have to budget with the funds you have. You have to think, well, for example, I work in Maseno. It's 30 kilometers from Kisumu. How long is it going to take me to reach there? When I'm driving or when I'm going by public means? So all these are mathematics which are solved very well by non-mathematicians. If we go back to the villages, most of us here in Kenya, we live in the villages, where there are farmers. When a farmer is planning for maximal produce, he has to calculate how much of his land is going to till and how much of fertilizer is going to use. He's going to budget that to maximize his or her profit. So all these are mathematics. So all around, I look around me, I see a lot of mathematics, and most of it is done by non-mathematicians. Thank you.
Thank you so much for giving us that reality check. It makes a lot of sense, especially when it comes to budgeting and even like distances and even managing time, if you will. There's an element of mathematics. Let's go to the next question, which is really linked to policymakers and informed decision. We often talk about data-driven decisions, right? So I'd like to ask Professor Philip Aguirre, about some reflections on how can mathematics help policymakers make better and more informed decisions. Over to you, Professor Ngabe. And remember to unmute yourself. Let us know if you're here and if you heard me.
Thank you very much. I've heard you. Actually, I'm here. I hope you can get me quite well. Now,
Professor, we can hear you, but we can't see you. I don't know if you want to be seen or if it's if you prefer to be, because sometimes of connection issues, you prefer to just be audio.
Yeah, I'll use audio because I think, let me try video, but it might not be very clear in the room where I am.
Don't worry. Then just stay on audio. I just wanted you to know. Go ahead.
Okay, thank you very much for the opportunity. I think during COVID period, it was, in many cases, the way it happened in Africa or in Kenya, many people who were seen to be infected were showing some symptoms. So in general, people are not known to be infected until they show some symptoms. So in this case, as someone who is doing stochastic analysis, it was possible to use some models called hidden Markov to be able to try to, like if someone shows some symptoms, it is possible to predict and say that maybe the way this person behaves, it is possible that this person has been infected. So you see, it has been relatively difficult for the policymakers to know how many people have been infected. So normally, when people show some symptoms, then you run to hospitals to seek for medical attention. This actually can be modeled using something called hidden Markov model. And actually, I think this is the work that I'm currently working on, just to see whether using this model, can we be able to predict the rate of infection, or to be able to tell how many people have already been infected. Because so far, as you can see, the numbers are rising every day. And I don't think that these are like new infections. I think it's possible that many people have been infected. It's not that they have not been discovered. So using this model, which is called hidden Markov, maybe it was possible to inform the policymakers whether the curve is flattening or not. So this is one application of mathematics that can be used to actually inform the policymakers on how the curve is going. Because as I've said it, let me not repeat myself, but what I've said is that so far, it is not easy to tell how many people have already been infected, because I think that they get discovered every day. So using some mathematical model, it is possible to try to estimate, using some probabilities model, to try to estimate, to show them like whether the curve is flattening, whether we have reached the maximum level of infection. And I think this will be very important for the policymakers, particularly in this unknown world of COVID. Thank you very much.
Thank you very much. Very relevant. For the same question about working with policymakers and helping them make better and more informed decisions, I'd like to turn to Professor Paolo Piccione, who's based in Brazil, to give us a sense of how can mathematics really support policymakers in making better decisions. Perhaps this is not the case in Brazil right now, but what are your thoughts on it? Over to you.
Thank you for the question. This is a very interesting question, Beatrice. I'm very happy to give you my thoughts on this. Let me start a little bit with some philosophical idea. So I think that the birth and development of science and democracy, they have a very strong element in common, which is the right of every human to search the truth. So that's my starting point, okay? So history teaches us that great scientific discoveries were driven by democratic movements, and because democracy offers a fertile ground for science. But at the same time, scientific advances help to establish democratic and equality principles. For example, demystifying prejudices that generate racism, gender inequality, homophobia, among other diseases that persist in our society. Mathematics has several ways to make our political and social institutions more egalitarian, helping to establish and consolidate democratic principles. Let us remember that mathematical models help establish more democratic voting methods. They help detect data manipulation and electronic fraud, assess equity in decision-making processes, study the dynamics of social phenomena such as poverty or infectious diseases, as we said. And also, statistical models can be used in anti-discrimination laws, as well as in the census. There are many areas of mathematics whose applications are very important for policy-making people. For instance, game theory, probability theory, statistics, combinatorics, optimization. Let me talk about something which has not been mentioned so far, but I think it's very important, like studying mathematical models for studying data about the population and its socioeconomic characteristics, the dynamics of populations inside the country. These models are very important for census. For instance, in Brazil, the census is done every 10 years, okay? And it provides detailed data on the country's population. And this is used to distribute political power and also direct public resources. So this is essential in a country like Brazil. And also, the results of census have been very important to create controversies and stimulate discussions, for instance, in the past about slavery and racial discrimination, for instance. As we said, mathematical models are strategic in the fight against the spread of infection diseases. And despite uncertainties, mathematical models guide public actions against the spread of the virus. So in this way, I think the mathematical model helps to establish the democratic principle of the right to health, right, of the population. Let me also finish with a little bit of philosophy on my side. Let me say another way that mathematics can really contribute to make a better political class, like math education. Math education is, I think, a very important point. Mathematical training stimulates people to creative and critical thinking, and I think this is very important for politics in general. So I'll finish with this personal remark. And
thank you so much. Thank you so much. It's really your link, also democracy and science, and the link to the census, and in a way also the distribution of resources among a population, which can hopefully, with the right way of doing that, also lessen economic inequality. So important, so relevant. And this brings us to the next question about how can mathematics attract more young people, especially women, especially because there is a gender gap. And I'd like to talk about that by inviting our distinguished panelists, our female mathematicians, starting with Professor Josephine Kagunda. I'm aware of the time factor. We are already at 10:03 on my end. It's 10 o'clock, so we have another 30 minutes. I'd like to invite you guys to stay to a 5-minute answer so that we have some questions, also some time for questions from our participants. So Professor Josephine Kagunda, please let us know a little bit about the gender gap and how to attract more young people, especially young women.
Hello, thanks once again for inviting me. I have worked a lot with young girls and women, especially in mathematics in our country and elsewhere. And the greatest challenge that we are having right now is the stereotypes that we have, especially in high school, where women and girls have a lot of factors working against their interest in math. And the first thing that we have is lack of confidence in the girls. We have very many women who can do math, but they lack the confidence to push through, because mathematics is a mental subject. It requires a lot of analysis. You have to be very patient, working through the answers. Sometimes they are wrong, so you have to do them many, many times. So one of the factors that we have discovered that can help us work through with the girls is by role modeling, showing them that you have done it so they can also do it. We also have encouraging outreach programs where we visit high schools so that we can talk to them, highlight to them the role of mathematics in the society, the kind of jobs they expect to have, because most of them think you can only become a lecturer when you do math. So there is research, there is data science, there is we work in the economy, in financial sector, and many other places. When you tell them and they have a one-to-one identity, somebody that they can identify with, then we usually find the interest is aroused and they are able to work together with their teachers and pursue mathematical careers at high school and also in colleges. The other issue that is very challenging, especially for our region in the sub-Saharan Africa, is lack of finances. We realize that customary, most families, they want to support boys because they think they're the ones that are going to hold their father's head, they're the ones who are going to remain in the family, and so investing in them is like you're putting things back home. But things are changing, and girls go back home and they help their parents. So we have to work a lot so that these girls also get funding. They have financial support to go through school just like boys do. Because if they don't finish high school, then we have no girls in the university. So we work from the grassroots, encouraging the parents to support their young girls. The other thing that now has come up is the use of technology. Because nowadays, if you're behind in technology, you cannot go nowhere. And therefore, we encourage girls to be curious, just like the boys. Use the phone, use the computer, play those games so that they can develop the skills that help them to build their confidence in the society. So the gender gap that we are seeing right now, we are closing in. When I was joining the University of Nairobi, we were 3 women out of a staff of about 39. Then now we have more women. They are coming up, they are graduating, and every year we are finding even the masters, the PhDs, we have female students. 1, because there is funding, 2, because there is role modeling, and 3, because everybody has taken the war. We are fighting together with the male counterparts to encourage women to do math. So what I can say is it's important to recognize the regional discrepancies and inequalities that are there so that we can do targeted assistance, role modeling, and support, especially for the women who are coming from very needy regions.
Thank you so much. I'm going to thank you so much because I would like the other female guests that we have as a panelist, Professor Winifred Mutuku, to also say a few words, and I'm conscious of the time and I want to make sure that there are some questions coming in and that we have the time to answer. So apologies for abruptly interrupting Professor Kagunda, but let me give you the word to Professor Mutuku, who is also an established and female mathematician in sub-Saharan Africa. Over to you.
Thank you very much. I believe we can, if we address the gender barrier to girls in mathematics, then that would be the right starting point towards addressing this problem of gender parity, especially in mathematics. How do we do that? we need to look at what are the gender barriers which exist and how can we counter those gender barriers. One of them is sociocultural norms, as alluded by Dr. Josephine, where we have attitudes towards women, we have gender roles which sort of prevent girls from uptake of mathematics. We have division of labor, which tends to give the girls more work to do at home. Therefore, they have very little time to study in mathematics, which requires a lot of time. Then we also need to look at, do we, our pedagogy, is it gender blind? So if it is gender blind, how do we address that? One of them is by looking at gender responsive pedagogy. Observations of class practices show that teaching and learning is largely gender biased. Many teachers apply teaching methodologies that do not give girls and boys equal opportunities. They use materials which can be seen as being perpetuating gender stereotypes. For example, if you're authoring a book, you'll find that most of the books we will have, they will give the roles of cooking to women and the roles of other like pilot, engineering, the names which are used, they will use that of men. So right from the materials we are using in class, we'll find that it is sort of discouraging to the girls. Again, the language the teachers use. It should be a language which is going to promote the uptake of mathematics by girls. We do not want to teachers saying, you do not have to perform so well, after all, you will get married. That is discouraging that girl. We've talked about the materials, and also in the lesson planning, it should be gender responsive. In selecting teaching methodologies, you should ensure that as a teacher, equal participation of both girls and boys. Then also the same should be perpetuated in the management of the class. You should allow both to participate. Then finally, from the government perspective, we should ensure that the affirmative action is applied everywhere. If it is in employment, if we have affirmative action, then we are sure that we will have more female mathematicians, as Dr. Josephine has said, and those girls will have a role model to look upon. Then we should also make sure that the mentorship programs reach out to as many girls as possible, and in those mentorship programs, the role models should be particularly women. Then if we were to address all that, then I think we could actually see the impact of that by seeing more girls taking up mathematics. Thank you very much.
Thank you so much. Thank you so much. That's a very important question, and I think you both nailed it. So let's move to the last question, and we are again a little tight with time, but we'll dive right in. How is Africa contributing to the evolution of mathematics, specifically thinking about Africa, because we have mathematicians here from different parts of Africa, women and men, established in their field. What is the contribution of Africa to the discipline of mathematics? And I'd like to start with Professor Ogana, I don't think is here. No, I'm sorry, Professor Martin Mugochi. Could you take this question and shed some light on this from your end? Over to you.
Thank you. Good afternoon, good morning, everyone. So I thought about this and I realized it's really a question which contains a lot. But I would like to answer it with a quick synopsis of my own, self-discovery, and development as a mathematician. So like everybody else, I started learning elementary concepts of classical mathematics in high school, and in the 6th grade, I wrote on on a piece of paper that when I grow up, I want to be a mathematician. So I saw, myself going in that direction. But it turned out that one of the years along my high school, we didn't have teachers who were coming in. So that really, I was doing very badly, in mathematics. But then I decided to start reading the texts that we had at that time, just going through them on my own, and that started just getting me going on and solving problems and so on until in senior high school. So I grew up in Zimbabwe, where I am from, and now I live in Namibia. But then during that time in senior high school, there was a mathematics Olympia that was running in the country. So I decided to participate in that. And I got a surprise of myself because I got the first prize, the gold medal for that. So from there, I started really literally launching myself into mathematics. That really reinforced, my pursuit of that. And so I realized as I was developing that, there are actually schools of mathematics that are also evolving during that time when I was now doing postgraduate studies. And one of them, in fact, two of them were coming out of the University of Cape Town. That was, as you move out of classical topology and all that, you're going into point-free topology. So there was a school evolving in that place. To the extent that in '91 there was development in colloquium lectures of what are called nearness frames, and I ended up doing my PhD in that area. And then another school also was developing in asymmetric topology through the late Hans-Peter Kunze. And then I realized as well that there was another school happening through Professor Lungu's efforts in Botswana, where he was working a lot with mathematical modeling, and from that some offshoots came out of that, mathematical biology and financial mathematics, dynamical systems, quantitative risk modeling, and so on. All these things were developing. And so you have groups of mathematicians working in all these different areas in Southern Africa and then and beyond. And some of them have really had experience with these particular schools I'm talking about. And just coming to Namibia with my family here, it was on my heart to say, we also need to be able to see young talent coming out of the schools. One thing that was lacking in this country, and that is still lacking, is mathematics Olympia. The development of young talent on the continent is not complete unless every country and region on the continent is involved. And Namibia has been left out in a major way in this mathematics Olympia competition year after year after year. And you find that some school children here, they go to South Africa to participate in that competition. So currently we are looking at serious partners who can actually assist us in launching this in this country, in Namibia. We tried, last year, but it didn't really, materialize. But we are at that stage where we are looking for that.
Thank you so much. This is quite fascinating. You said mathematic Olympians is like Olympics for mathematics. Is that what you said?
That's right. Yes.
Wow, that is an interesting concept. I never heard of that, but it makes a lot of sense. And I was wondering, because Professor Ogana is not here today, if Martin, if you can say a few words about the African Millennium Mathematics Science Initiative. Are you familiar with that? Can you say a few words? Right. Because I know
I'm quite happy. You see, what happened incidentally, that I was funded by AMMSI during my PhD studies. The final 2 years of my studies, I received funding from them, and that's something I'm quite grateful about. It is an initiative to actually develop, young mathematicians in their postgraduate studies and so on. And some of my colleagues here have also benefited in their postgraduate studies, in their master's program from AMMSI.
So it's the AMMSI stands for Africa Millennium Mathematics Science Initiative, right?
That's right, yes. Yes.
Awesome. So is it possible for this question about Africa and how is Africa contributing to the evolution of mathematics for Giovanni Marelli, who is an Italian researcher at the University of Namibia?
Yes, so
Say
I
a
can.
few words. Thank you.
Yes, just a few words about my experience. So, first of all, we hope that in the future this exchange of scientists may grow. So more African scientists can go to non-African countries and work there, and conversely, non-African scientists can come also to Africa for doing mathematics. Now, following mathematics, I've been traveling to many countries. Now I'm here in Namibia. Mathematics itself is a travel when one can discover and learn beautiful and amazing ideas, and hopefully also to contribute to them. And so the travel, both an inner travel as mathematics, but also physical travel, moving from one country to the other to do mathematics, is enriching, and it helps question oneself, and so to be able to understand and to catch new ideas. And the travel always has a return, which is a rediscover of oneself. So it's an enriching experience. Regarding Namibia, now the time is very short. I can just point out just some problem that is also related to the purpose of this roundtable, is that maybe resources and energies are not used in an efficient way. For example, here at University of Namibia, the number of staff members should be increased. Now, this is not fault of the university of lack of goodwill, but the matter is just a lack of funds. So, of course, quality is a cost, and it cannot be left to the goodwill and the enthusiasm of few people. So I hope that an event like this, that hopefully will be the first of many others, will help to show to the world what we are doing here in Africa, to show which are our problems, and hopefully this will contribute to an improvement of the situation of mathematics and science, and so of society in general here in Africa. So these are just the few thoughts that...
Thank you, Giovanni. Thank you so much for that. I'd like to actually bring in Frank Newman as well on this question about the contribution of mathematics as a discipline within Africa and from Africa. Frank, would you like to weigh in on this question, please?
Yes, thank you very much. I really enjoy this discussion, and it's very broad, and I can say several things. I'm a pure mathematician. I actually work on algebraic geometry and algebraic topology, and with some application to number theory in geometrical ways. So, of course, you might ask, what is the influence of pure maths? But one thing one can definitely say is, it was already mentioned, that areas like data science, epidemiology, and climate change research are directly linked with African input, because the data is there. I mean, Africa as a continent is one of the most important resources of humanity in every aspect, culturally, biologically, and so to preserve this is a human entity, and I think African mathematicians can be pioneers here because they have access to data in all possible ways. And for example, I think the way how other continents like Europe or Americans dealt with the pandemic, or not dealt with the pandemic, I think, compared to African situation, where people are used to pandemics and know how to react fast and strongly, shows a difference. And I think one can learn here from African countries a lot. And I think there could be a lot of synergy between African researchers and researchers in other continents to do that. And let me just say also, for pure mathematics, of course, the education of mathematics is very important. And I see that my colleague and friend Frank Kalala Mutumbo is here. He's an academic director from AIMS in Senegal. And so I had the chance to give some courses there at the AIMS Center in Senegal. He invited me on just basic mathematical problem solving, but I was really impressed about the enthusiasm and the motivation of students. These were young master students to solve problems. And, you know, you can really mathematics is, as we know, and as Paolo also said, it is independent of where you come from, what your background is. If you're a man, a woman, or any other gender, I think you have mathematics is, it's really this subject per se, which does not provide any barriers. And I think institutions like AIMS help there a lot. And I know that, for example, in one of the centers, if I'm not mistaken, in Rwanda, they really want to work on quantum computing. So it's like, okay, let's just jump another process and just go into it. And if there's enough critical mass, I think one can do a lot of things. And I think there's a bright future for mathematics in Africa. And what is needed is resources and politicians to understand this, which is of course always difficult. But I think there could be a way of really showing that if you do mathematics, it's actually a cheap subject compared to other subjects. If you have elementary particle physics or engineering, you need a lot of investment, or chemistry, you need a lot of labs, of course. But mathematics, I mean, besides the computer systems, which are important, especially for data science, is a quite cheap subject, and the basics can be taught easily. You can teach mathematics anywhere in the world, if it's in the desert, in the jungle, or in a big city, or at the sea, wherever. Mathematics can be done at your place at home, and I think that is really good. And I think these kind of discussions we have here today, which I'm very happy about, is that it really helps to connect people. I mean, we have this pandemic worldwide, which is very bad and sad, but on the other hand, we also have the opportunity to get together. And I've seen lately that the mathematical community got a lot together through conferences, online, and so on. And I think there's a big chance here that this continues, and isolation is something from the past, and we have a chance to be all together with this. So as a mathematical world community, I think.
Thank you so much, Frank. It's very inspiring to wrap up the roundtable with this particular view of how Africa also has a lot to offer, and in terms of for the discipline of mathematics, and how mathematicians throughout the continent are getting together, are connecting, are exchanging ideas, and coming together regularly. I'd like to open the floor for questions at this point. I've seen a few come up in the chat, but let me read one particular question. There was a question about if Africa has, how mathematics has been used, if the modeling of mathematics, has it been applied also to the fight against cancer? Can anyone reply to this specific question or feels comfortable? If you do, unmute yourself. Maybe one of our colleagues who has experiences in infectious diseases might also want to address this issue of not an infectious disease, but of cancer. So if there are no takers for that question, you can think about it. In the meantime, are there any other questions that can feel free to put them in the chat for any of our panelists? So Philip Ngare did write, for your question on cancer, there are mathematicians who study diseases called biomathematicians, biostatisticians, who spend many times studying diseases, infections, and spread to see patterns, and also to see how many people get treated following drug testing. Thank you so much, Philip, for that, for answering that question. Anyone else with a pressing question for it's a unique time as well, to an opportunity to ask any question, even also related to the pandemic and mathematics, to our distinguished guests here today. Yeah, there's a question here from Luca Giugiuli. What is the general flavor of mathematics education in Africa? are any of the areas of PDE, I'm not sure what PDE stands for, dynamical systems, pure math, or machine learning more developed than others in Africa? Is there a taker for this question? And whoever takes it, please also explain PDE as an acronym.
I'll take that. So basically, we have different research areas in Africa. We have people who are doing partial differential equations and their applications in day-to-day life, because you'll realize that most of the problems mathematics addresses, when you convert them into equations, you either get what you call ordinary differential equations or you get partial differential equations, which you need to solve to get a solution to the problem which was being addressed. We also have dynamical systems, and you'll find that people who are doing mathematical modeling of diseases will actually need to do a lot of dynamical systems to understand the dynamics of the disease. We also have areas of pure mathematics, and I think among the panel we had people whose areas of specialization is mathematics, and I could say machine learning or artificial intelligence is a field which is upcoming, and there is some research which is being done on that particular area as well. Thank you.
Thank you so much for answering this question. Are there any other questions for our panelists from anyone in the audience? Feel free to drop it in the chat. And I see Martin. Yes, there is a question about, let me give the word to Martin, and then there is a question about predicting the end of the pandemic. Martin, over to you.
No, I just wanted to add quickly to, are there more other areas developing that I saw in that question? Yes, in the direction of those PDEs, I know we have a colleague here, or two colleagues who are working in the area of fractional differential equations, which is, we're finding that quite interesting. It's something that's developing around here. So yeah, just a comment about that. I'm not in that area, but it's an interesting thought.
Thank you so much, Martin. We have a very important question about predicting the end of this pandemic. Would anyone dare to take that on? Otherwise, I might call on you, because whoever answered the question before, we had Josephine Kagunda and Patrick Ugeweke who answered the question about pandemics. But basically really is, can mathematics help us predict the end of the pandemic? How does mathematics, I would like to add also, can apply to the rollout of the vaccine and how it's going to be accessed in different parts of the world? Would anyone like to take that? And maybe this might be the last one.
Let me respond, although Josephine is the real expert in this. I think the mathematical models for pandemics concentrate more on determining when the peak will occur. It can also propose the end of the pandemic, but that would have numerous errors because of the factors involved. If you take a country, for example, what kind of measures has a particular government taken? Do we have lockdowns? How do we allow free movement of people? How do people wear masks? And all these other things. And so it may be difficult to, use a mathematical model to determine accurately the end. But of course, the fluctuations are easy to understand, and the peak, whether it's the first phase, the second phase, the third phase, that is much easier to determine. Yeah, sure.
Thank you so much for attempting to answer that. And of course, it sounds like it's hard to predict when it's going to end, and there's so many other factors that are involved. Please, if everyone could, we hear some background noise. I want to make sure that. Yeah. So I want to thank everyone. We are at the end. We are at the end of this roundtable. I want to thank everyone who has participated, and especially all the guests, the panelists that we've had today. A special thanks to Professor Frank Newman and to Professor Martin Mugoce for even thinking about this event and bringing people together from all parts of Africa and beyond and different continents. I want to express gratitude for even inviting me. I've learned a lot today from each and every one of you, and I hope that you will do this again, and I'll be sure to follow you. And I hope there were some journalists who were able to take your names and jot down your names and possibly reach out to you for being potential source in some of their stories as they try to make sense of the pandemic and might find value in speaking with you. I'd like to close this session and remind everybody that this recording will be available on the MARM website in the next few days, and I think that Frank dropped this in the chat and might, so it's somewhere over there. Otherwise, Google MARM. Perhaps, Frank, if you could drop it again, that would be great.
I can maybe,
yeah.
I would like to say something.
Yes.
I think it will be actually on the web page of the MARM nodes, not of the MARM LMS web page, but we can also put it there. But I should thank to Letterio, who actually initiated all this, and to his colleagues in Namibia. I think it's a fantastic opportunity we have here. Thanks also to you, Bea, for hosting this, and to anybody else who came. Paolo from Brazil. So we met here to come to Africa to do this, even though it's hosted somewhere virtually. But I think we had a great discussion, and I hope there will be more of these following. Maybe some of the other MARM nodes will follow, and we will have some inter-MARM discussion as well. And you know, it is good to see that we can get connected, which I think is very important, because one of the main problems we had with some of the MARM projects before, these are small scale projects financially, but I think they're like seeds, and if you have these seeds growing, you want to connect them at the end. So you have seen the map I put at the beginning. The problem is to keep in contact and to try to connect again. So, and I think it's very important, because you know, it's like with seeds, you have to water them, you have to make sure they grow, and then you know, they contribute to the landscape. And I think that is really important to create an African mathematical landscape. And if the LMS can help, we are not here to tell you what to do. We just can assist, give some ideas, and listen. And I think it's important for us to listen. And I think that's what we did today. So I'm very grateful to Letterio for initiating this, and to Martin to do this on their MARM node. Thank you.
Thank you so much. I see someone has added the video link. Go ahead.
Can I add just...
Sure.
The only thing I think I should add to the kind Frank words are very special thanks to Miss Beatrice Spadaccini for the excellent job she did for the mathematical community in moderating this roundtable. So I think on behalf of all the participants of this meeting, thank you very much, Beatrice.
It's my pleasure. Thank you, guys. Well, stay safe, be well, and looking forward to seeing you again. Thank you.
Thank you, and bye.
And bye.
Goodbye.
Stay safe.
Goodbye.
Bye.
Regards from Leicester. Bye.
Bye. Bye. Bye. Bye-bye, Sumaya.
Goodbye, Letterio.
Goodbye.
Goodbye, everyone.